My name's Nick Schneider and my project is Zen, which is a relaxation device which uses brain activity monitoring. Essentially it's an EEG headset. EEG measures electrical signals that are produced by your brain, and from those signals you can deduce the emotional state of the user. So we're talking about things like attention and meditation, and in the device you use focus and relaxation to control the movement of the ball. In this project, the current state of development with the electronics is potentially 60–70%. All the major systems are in place, they're all working, they're working separately, and really through the last part of the development process I'll be looking to combine these systems together to make a completely functional prototype. Aesthetically, the product is possibly slightly more resolved than functionally. Perhaps looking at 70% resolution of the aesthetics. One of the main issues that's been raised with this project is it really a useful device? Is it really necessary? So one of the key things that I need to look at is from a user perspective. Are users going to interact well with this device? Is it something that users are going to cherish and enjoy using, or is it something that they're going to become fed up of quite quickly? I'm very confident that it's something that they're really going to enjoy using, and user testing has helped me to prove that. There's quite a lot of electronic prototyping within my product. First of all, we'll start with the EEG headset, and that interfaces via Bluetooth to the central unit within the device. So the first thing there is to get the Bluetooth communications working, which I've done successfully. Then secondly, everything is controlled via a microprocessor. In this case, I've used the Arduino platform, which is an open source hardware software platform. It's designed for quick development, and it's really helped me throughout this project. So the Bluetooth interfaces with the Arduino board, which then controls a range of peripherals, a motor which drives the device forward, a servo which controls its directional movement, an infrared location system, so the device always knows where the user is, and then other peripherals, LEDs, switches, etc., etc. The strategy that I took was really to prototype the systems individually. So I looked at Bluetooth communication as a discrete project, and then looked at driving the motor as a discrete sort of project. And then the end goal now is to combine all those discrete aspects into one fully working prototype. I've spent 70% of the total project time on electronics. I've had two different sets of wireless communications to implement, so the Bluetooth and also the infrared system, which has been quite involved. And then a range of other peripherals, the motors, the servo motor, LEDs, etc., which all needs to be controlled by the microprocessor. So it's been quite involved electronically, but the aesthetics hasn't been left out. Had quite a high level of detail in resolving the form, which I'm also quite pleased with. I don't feel as if the time I spent a lot on electronics has negatively affected the project, specifically negatively affected the aesthetics. I think in a lot of ways you have to be realistic about what you can achieve and where the emphasis of your project is. If you have a slightly more electronic emphasis, you can quite understandably say that perhaps the aesthetics might not be as resolved as you'd like them to be. But within the perspective of the project, that's actually okay, that perhaps some more impressive electronics, some more resolved electronics caters for the lack of resolution in the aesthetic side. But specifically to do with my project, I don't feel like it's suffered negatively. In lots of ways I feel like it's made me use my time resolving the aesthetics very wisely. It's made me work very hard at that side of thing and very efficiently. at the aesthetic side. The main system that I've used throughout my project is Arduino. It's an open source hardware and software solution. It's designed for quick development. There are lots of libraries of code online that you can use to program the electronics. Tends to speed up the process, tend to be able to develop something or a concept a lot quicker than from first principles. Which is why I chose it for my design, and it's been very successful throughout. In addition to that, I've used a microchip in the aesthetic prototype, and that is programmed using a piece of software called MPLab. It's essentially writing a program telling the microprocessor what to do, that you write onto the chip, and as you would expect, or most of the time, it does what you say. The most difficult aspect has been to get the electronics and mechanics of the device to interact successfully together. So perhaps in some projects you have your electronics which are functioning as intended, and the electronics interact with the user. In this project, there's also a mechanical element, the motor driving the ball, controlling the direction of the ball, and there was a lot of testing which had to be done, a lot of tweaking to the program, to the hardware, before the design was stable and it functioned as I intended it to function. So in terms of how did I solve these issues, mechanics and electronic integration, it was through testing, it was through refining the program, refining the hardware, and one of the great flexibilities of using Arduino is that the code is generally quite easy to alter, so you can alter the program. That was combined with, I designed the functional prototype specifically so that the design could be flexible, so that it could change. I started the project being quite adventurous. I came up with a few interesting ideas, such as using induction charging to charge the device. The benefit of this is that the user doesn't have to change any batteries, and the design of the housing and the electronic system itself can change as a result. Unfortunately, I have had to pare that induction charging back. I was hoping to be able to implement a system and to test the system, to demonstrate its feasibility, essentially a proof of concept exercise. Unfortunately, I haven't had time to do that. That's something that I'll evaluate at a later date. I know from research that it is feasible, but it was a case of not quite having the time to be able to implement that at this stage. In reality, I chose this project because it has a balance, yet it perhaps leans slightly towards the electronic side, but there's also mechanics, there's also ergonomics, and there's also aesthetics. So it's again trying to have a rounded skill set as a designer. But I did focus quite heavily on the electronics. It was something that was slightly daunting. Sometimes things that you think would be easy to implement are very difficult and problematic, and sometimes the opposite's true. The Bluetooth communications in the device was a lot easier to implement than I thought. I've done research into the coding. It's quite a difficult or complicated system by which the two Bluetooth modules talk to each other, essentially. But actually with available coding libraries, that was quite easy to implement. Whereas the infrared location system, I built from first principles. So all the hardware and software I developed myself. I thought that that would be not an easy task, but a task that was achievable. And as it turned out, it worked to a certain extent, but for the benefit of the project, I ended up buying in a module which did exactly what I want. So in terms of proof of concept, building from scratch worked, but just getting that extra little bit of resolution that I wanted required buying in a module. I think you have to make compromises of what you intend to do to what you actually have the time to get done. But that's not always a bad thing. I think a lot of it is about knowing when you should stop and understanding that a lot of these prototypes are proof of concept rather than something that's fully working. So I'm happy with the progress that I've made. inevitably there's a small part of you that, you know, wants to get that extra bit done, wants to get the extra detail done, the extra part of the code done. But again, you have to be realistic about the time that you've got. So within the time constraints, I'm definitely happy with what I've achieved. That's certainly not to say that there isn't a lot more that could be done. I think if I could have done a part of the project differently, I would have taken more time to consider what components should be bought in and what components should be made myself, or more specifically, what systems I should make myself. If we look specifically at the infrared location system, initially I started building that system from scratch, from first principles, which was very time consuming. I probably spent 2 weeks alone just on that system, and began to see that it was a very involved process which would require a considerable amount of time. I think one of the benefits of doing a project like this is learning when to stop pursuing something and when to say, okay, now it's time to try a different approach. I think that's key, and that's something that personally I learned was very key to a project, is when to say, okay, let's try something else now. So if I would have done something differently, I perhaps would have said that at an earlier stage about parts of it, like the infrared sensor. But I think it's in the nature of a designer to want to resolve something, whether it's perhaps not entirely the right path, or whether it's sacrifice for something else, that you want to resolve something, then you've got the kind of mindset that will sort of continue to wrestle with that. Prior to university, I had quite a good knowledge of electronics. For GCSE, I did systems and control as opposed to product design or resistant materials. So it enabled me from a fairly early age to become involved in those sort of things, and having an engineering mindset also as a younger child meant that I was interested in that kind of area, the area of electronics. And then coming to Loughborough University and being able to do the BSc course allows you to explore the area of electronics a lot further. So this is Zen, a mind control relaxation device. The first stage is that the user would take an EEG headset. This is an existing headset. Place the headset on the head and fire the device up. Pair the device with the Bluetooth in the headset, like so. That means that electrical signals in my brain that indicate attention and relaxation are being measured by the headset and being sent to the device. This is a working model of the electronics of the device, which I'm currently developing a housing for. Essentially takes these signals, uses them to control a motor, a servo motor, which controls the directional movement of the device, and an infrared location system, so the device knows where the user is.